Hello, I have downloaded our new homework. I will put my GitHub repository to track our progress. Okay, let's open it. Our repository is CENG4207. Okay, it's about the logistic regression, as we see in the course. I will copy and go our yes. And as you see that it will create all necessary files. Okay, now I will send to push the origin and open PyCharm for this. Okay, I have opened PyCharm and open new project. Select this and okay. Trust project, yes. As you see, our homework is there's some update in PyCharm. Yes. This is about logistic regression. We will create new local interpreter for this. Okay, don't worry. I will just summarize this. Let's check our test utils. This is about testing our code, and this is about loading data. I think it's map feature, it's just mapping, plot data to sketch something, I don't know. Plot decision boundary. Okay, it will decide credit. Okay. First of all, let's create our virtual environment so that I will open. If I try to run this code, it will fail. Okay, notebook package being installed. MATLAB error writing. I don't know. Let's create. Here is the settings. Here is our project. Here is our Python interpreter. Okay, we will create a new interpreter for this project, new virtual environment. Okay, now it's just pip. Okay, and apply. Okay, that's some time. If I try to import these things, okay, it will try to start Jupyter server. Okay, let's install NumPy here. Add NumPy. Okay, install this package. Okay, then matplot lib. Okay, install it. Okay, system just a few minutes. I will stop the recording. Okay, we have some matplot library. As you see, first it's just sorry, it's just just pip and the other library. It was NumPy. Then we install matplot library. Okay, so that it's install all necessary files like Jupyter and other stuff. Okay. Integrated development environment, integrated development environment can do this alone. And this utils is not a package. It's from this. I think it will. Sorry about my phone. It will use. We can use this functions in our file so that we import it. Okay. Then let's create. Okay, let's continue. Start this importing necessary libraries. Okay, logistic regression, part of exercise, you will build logistic regression model. Okay, students get admitted into university. Okay, good. Problem statement, supported you are administrator of the university department and you want to determine each applicant change the. Okay, I will go section by section. Okay, first of all I will read all page for myself and stop the video, and I will do exercise one by one and explain each sentence, each line to you, so that I will pause video and start reading the other stuff. Okay, but before we go, as you see, there is some data here and exercise data here. As the image, I don't know, but in load data, I think load data, if I check load data in, yes, as I guess util data, if I put some breakpoint here and come back our file and try to debug, not run, debug the cell, it will go, yes, our data is here. And if I skip one line, step over, as you see, the x values are there. Okay, are here. Let's look at it. Now step over. File name, exercise 2 data 1, exercise 2 data 1 here. Yes, sorry. And okay, I take all of it and just the part is like a classification, I don't know. Okay, let's continue. Print x5 element in here. Let's run. Yes, this is our first 5 element in x training. And now print the y values train. Okay, just y values. Yes, type of is numpy and array. Okay, check dimensions of your variables. Another useful. Okay, it will, as you see, the first 5, and it's the type of like a collection and array. Check the shape of x train is and shape of y train is, and we need the training sample. Okay, the length of the training sample. Okay, shape x 102 and 100 and nothing. We have 100 training examples. Before starting to implement any learning algorithm, it's always good to visualize the data if possible. Okay, this are data, admitted, not admitted. Okay, there's some sketching codes in here. It's from, I think, MATLAB or Matplot, I don't know which one. It's Matplot library. Okay, I will stop video and continue to exercise 1, but before stopping the video, let's show the sketch. Yes, okay, it's admitted and not admitted here, like a classification problem, like we see in lesson week 4 and week 3, I can't remember. Okay, let's do our exercise. May I, sorry about I have said 1000 times I will stop video, but now I will stop it and solve this problem and explain each line of code. Okay. Okay, let's continue. There is some sigmoid function commonly used in logistic regression and neural networks. Maps input values to a range between 0 and 1. It's particularly useful when we want to interpret the output as probabilities, such as binary classification problems, where the model needs to predict the likelihood of an event happening, like the student being admitted based on their scores. Okay, so let's start our code. I have disabled yes this disabled for to write better because it predict and like a shading for me. Okay, we will define our g here. In Python, when we create a variable, we don't need to specify integer or float or double or any class. I don't know. It's when we assigned, it will decide which variable it will show. Okay, I will use, I think, I don't know. Okay, as you see in here, 1 divided by 1 plus, I will use numpy function exponential function minus c. Okay, sorry, I won't misspell. Okay, and let's return g, define our function, and let's print. Yes, it's sigmoid 0, it's 0. Or 0.5, it's correct. Okay, and run this code, and the output is true. Okay, there's why is t, I don't know, maybe I can correct, but this is public test file. Let's use sigmoid test, but I don't want to corrupt. Okay, let's continue with exercise 2, cost function for logistic regression. In this section, we will implement the cost function for logistic regression. Okay, we did sigmoid function. Now let's logistic regression. As you see, we have seen in lecture. Please complete cost function using equation below. Okay. Recall for logistic cost function where m is number of training example in VCX. I think I can't remember. Okay, in the cost single data point, which not scalar values matrices respectively, where n number of features, m is a number of training example, you can use sigmoid function. Okay, I will stop video and solve this question. Okay, let's continue. It is in sigmoid function we decide 0 or 1, but in this function here we compute the loss. Okay, how good we are, we can see. Okay, in this here get the, I will explain one by one. mn is dot shape. Can I see dot shape in utils file? I don't know. Yes, public test, but I don't know this x or returning n. Okay, and get the number of examples m, number of examples plus n, and features it's n from the shape of x. Okay, M is number of training example, N is number of features, okay, like we see in lesson. Then compute Z as the linear combination of weights and features, okay, and Z equal to, I will use numpy function, numpy dot x and w plus b. In here Z is a M comma nothing shape array, and we will see that when debugging the code, okay, and it's like some blurring because we didn't use it, okay, so that it's blur. Can I say okay, and apply the sigmoid function to Z to get predictions. It will be better when seeing on the code. I can understand better. So thanks for homework, but sorry for late submission. Sorry, I'm writing same code. In here we apply the sigmoid function. As you know, we have declared here, so I can use again because it's sigmoid function is this, okay, and we have implemented here, so we can use it. Yes, we equal sigmoid, yes, Z and or underscore b, it's model predictions is also shaped, okay. Then calculate the loss for each training example. Calculate the loss for each training example. Okay. Training example. Okay. Let's declare loss equal minus y times, I will use numpy function, log. Then in here we use sigmoid function b, the result of sigmoid function, minus 1 minus y times p, the logarithmic function, 1 minus b. Okay, let's try explain this. Minus y times mp log fb calculates the loads when y is 1. I'm in the positive class, okay, but the other 1 minus y times mp logarithm 1, sorry, it's minus 1 minus, because as we see in the lecture, it's showing the two case, okay. If 1 is positive, it's let's say y is 1, then it's 0, okay. So skip this, just calculate this. But if y is 0, then this part is 0, okay. Then we can see the both case in here, okay. Let's finish our code, then compute the total cost as the average loss over all examples. Okay, compute the total loss. Okay, for this total, let's create some total cost variables. We will return in the class. Let's just here 1 when m times mp with sum, yes, sum all, and yes, it's end of the code. Let's return the total cost as color. Let's look at again. Yes, when y is 1, skip this part, just here, then y is 0, it's kill, omit this part, just calculate here. Okay, I'm a little bit excited. It's working or not. Okay, there is no error. Then see the expected result. Okay, very good. Let's test the other. Sorry, test it. Yes, it is correct. Then the exercise 3. Let's do this part. Okay, then as usual I will stop recording and do this part. Okay, let's stop. Okay, let's continue. As we see them compute gradient, let's give a quick brief and gradient and its purpose. The gradient is a vector that indicates the direction of a rate of steepest increase of a function. Okay, in this context of logistic regression, we use gradient to determine how to adjust the model parameters, I mean the weights and w and bias and b, to minimize the cost function. Okay, our purpose is minimize the cost function. The purpose of computing the gradient is to perform gradient descent on optimization algorithm that iteratively adjusts parameters in the opposite direction of the gradient, minimize the cost function. The lower the cost, the better the model prediction aligned with the actual values. Each step of gradient descent calculates the gradient of the cost function with respect to each parameter. Sorry, I have some issues. The lower the cost, the better the model prediction align the actual values. Each step of the gradient descent calculates the gradient of the cost function with respect to each parameter, which help us update W and B, achieve better fit to data. Okay, if you don't have how can I say heavy data, you can use this optimized function. Okay, we have sigmoid function before, we can use it again. And this here, get the number of examples and features, initialize gradient to 0. That's right. Here it's initial. I'm very bad at this word. Initial, okay, and lies. Yes. Gradients to 0. Okay. Gradients to 0. Then step 1. Let's start with step 1. Okay, calculate z and predictions f will be. Step 1. Calculate z and predictions f will be. Then z, it's mp dot x and w plus 1 plus b. Okay, as shape shape and comma. Okay. Then fb equal to sigmoid. As you remember, we write here the sigmoid function. Okay, so that we can use again sigmoid z sorry. It's shape and comma. Then write it. Predictions for each example. Okay. Now step 2. Let's go step by step. We have calculated z and predictions, and now calculate the error term. Okay, then calculate the error term. Its error is f minus y. Okay, and where is y? Y is here, a parameter of this function. Okay, the actual value. Difference between predictions and actual values. It's shape and comma. It's actual value and the prediction. Okay. And let's go step 3. Step 3. Let's go. Step 3. Calculate the gradient with respect to derivative respect to b. Let's write dg db. Okay, let's declare db equal to 1 over n times np, this numpy function, sum error. Let's give error. Okay, and it's scalar. Then step 4. Step 4. Let's calculate the gradient with respect to w. Let's call it with dg. Sorry, it's differentiate dg. Okay. Then w. Sorry. W equal to 1 over n. Let's use numpy function np dot and give the parameters x, t, error. Okay, its shape, number of features, and dot product, sorry, misspelling, to some error feature across examples. Okay, end of the code here. Okay, gdb dg. Okay, I'm a little bit anxious here. I think we did right. Oh, yes, we have created with the 0 and given new values here. Okay, it's zeros, bunch of zeros. Yes, just one scalar value. It's a shape. Okay, let's run this code. Okay, then test it. Okay, it's true. Okay, I'm glad with that. Yes, all tests passed. It's very good. Now, learning parameter using gradient descent, as we discussed before. As usual, I will stop recording and solve this question. Okay, let's continue. It's taking a lot. I don't think so. We write some code in here. It's just talking purpose of the gradient descent. Gradient descent is an optimization algorithm used to minimize function by iteratively moving towards the minimum of the function, so that we allow context shapes, okay, because we don't stuck in the local minima. In the context of the machine learning, it's used to adjust the model's parameters, weight and bias, in order to minimize the cost function. Okay, and J, that's cost function, which measures the error between prediction and actual value. The goal of the function gradient descent is to iteratively update parameters W and B, okay, and to minimize cost function of J. The result of the model makes more accurate prediction. Sorry, let's run this function. Okay, let's test it. It's made up. Okay, expected result are true. It's plotted. Some missing, but it's good. Right. Okay. Now continue with the exercise 4. Evaluating logistic regression. Okay, let's continue. Exercise the predict function to produce 1 or 0 predictions given a data set, learned parameter vector W and bias B. Purpose of the predict function is use learned parameters W and B of logistic regression model to make predictions of new dataset X for each example in X. Okay, function calculates the probability that label 1 in the positive class and applies threshold of 0.5 to classify each example as either 0 or 1. Okay, then come here and explain one by one. Okay, in here a number of training examples. Another initialize init predictions vector to all zeros. Okay, we initialize that. Then start code. Let's go step by step. Step 1 is compute the linear combination of X and W, then add B. Okay, Z equal to, if I can type, okay, np dot product. Let's give the parameters X and W plus B. Okay, let's shape and 1Z for each example. Okay, then step 2, apply the sigmoid function as we did before. Sigmoid function to compute probabilities, probs. Okay, probabilities it's in here, yok. Okay. Probabilities equal sigmoid z. Okay. Sorry. Then step 3. Apply threshold okay, of 0.5 to make predictions. Yes, p equal to if probabilities greater than equal 0.5, greater than equal 0.5. Now we are giving a type s type integer if probability greater than equal 0.5 predict 1, else or otherwise predict 0. Okay, then return p. Yes, it will. Oh, predict is not defined. Why? Call random. Predict is not defined. Why? Oh, sorry, we didn't. Yes. Okay. We have to run all this code because we write predict in this code. Then we will use it. Regularization, holistic regression. Okay. This tough homework. I'm checking it's 14 minutes already passed. Yes, problem statement, loading and visualization the data. Let's load data again. Okay, that's printed. We did before. Okay, I'm just skipping this part. Okay, there's some circle here. Okay, let's plot it. It's using MATLAB. Plot library. Then feature mapping. One way fit the data better, create more features on each data point. The provided map feature will map like a mapser in C# and .NET. Map feature here. Okay, original shape of data here. Yes. Cost function regularization. If there's some unnecessary weights, we decide lambda. Okay, lambda is important, not too small, not too big, or not 0. Okay, lambda is crucial to compute. Okay, let's dive in exercise 5 and exercise 6. There is more exercise. I don't know. Yes. Exercise 5. Okay, I will stop recording. Okay, let's continue. I have solved this part. Let's take a look. Purpose of regularization. In regularization, logistic regularization help prevent overfitting. Okay, by adding a penalty to large weights. This penalty term called regularization term helps keep model simpler and more generalizable by discouraging extreme weight values. Okay, by using logarithm, as we see in lecture. In this function, we calculate the regularization cost by adding regularization term to original cost function. Okay, then as we did before and before, number of training examples. Then compute cost function. Compute cost. Where was the compute cost? Sorry. compute gradient. Yes, compute cost. This was a very long homework, so that I'm sorry, it's hard to remember because we already defined this function. Okay, compute cost, cost without regularization. Okay, then initialize. Okay, initialize the regularization cost. Okay, 0. Then start coding. Okay, then first compute the regularization cost as the sum of squares of all weight in W. That's right. Compute the regularization's cost as the sum of squares of all weights in W. Compute. Okay. Reg cost equal int some numpy function sum star 2. This is square each and sum them up. Okay, that's it. Then add the regularization term, the original cost. Okay, that's just one line of code. Then test it. Okay, regularization cost here. Okay, then continue with exercise 6. Am I reckoning? Yes. Let's continue with gradient for regularization logistic regression. Let's brief explanation. The purpose of function is calculate the gradient for logistic regression with regularization. Regularization help prevent overfitting by adding a penalty term, the weights which discourage large values. Okay. Then let's, as you know, it's number of training examples. Okay. Calculate the, yes, right here, calculate the standard gradients without regularization. Okay, without standard, sorry, yes. Then add regularization term to the gradient of the W equal to W plus lambda over M times W. It is regularization applied only to weights, not to yes. Okay, and B. Okay, let's run this code and test it. Yes, all tests passed, as you see. Then learning parameters using gradient descent. As you see, initialize fitting parameters and the expected result. Okay, that's all true. Let's plot it. Okay, then let's predict it. Okay, it's true. Thank you for your time. It was very good examples, and we have covered all examples here. It was very good homework. We have seen sigmoid function, cost function, gradient descent, discount prediction function, regularization, gradient descent. It was sequence of step with logistic regression model that can predict binary outcomes effectively while avoiding overfitting. Okay. Thank you for time. It was very good homework, and sorry for late submission, sir.